In this problem, we are given the figure shown. Friction at the pivot P is neglected. The right angle uniform center bar ABC has weight W. If the weight of the bar is 100 newtons, we are tasked to compute the minimum weight of cylinder at D to cause loss of contact at A. To solve this problem, we let the weight at D be equal to W. Knowing that the overall weight of the bar is 100 newtons, and this length here is just 1/3 of the total length of the bar, therefore the weight carried on this bar here is just 1/3 of 100. So this is 100 over 3 newtons. And for this bar here, where the weight is acting on the centroid, this has a weight of 2/3 of 100. So this has a value of 200 over 3 newtons. And in drawing the free body diagram, there is a reaction here at C. Let's call this N sub C. And for the pin support, this has a reaction at B. Let's call this B sub Y for the vertical component. And for the X component, this is B sub X. And since we're assuming a loss of contact at, this should be C, therefore the normal force at C should be equal to 0. Therefore we can erase this and neglect this force here. Now we can solve this problem by taking a moment at point P, but first let's try to observe the free body diagram on this pulley right here. So let's try to cut this segment here and analyze its free body diagram. So we have a pulley and a force W, which is the weight of this block here, D, that we need to solve. Let's call this W, and then two forces going up. So by symmetry, the value for these forces here is equal to W over 2. Now we can start analyzing this slender rod. So by cutting this segment, this has a force here going down that has a value of W over 2. Now by taking summation moment at point P equal to 0, considering counterclockwise to be positive, we have the 200 over 3 Newton force that will induce a clockwise moment, so it's negative, times its moment arm distance, given this is 2L over 3, therefore half of it is L over 3, so its moment arm distance from here to here, given this is 30 degrees, therefore this angle here is 60 degrees, so this distance here is equal to L over 3 times cosine of 60 degrees, and then plus the 100 over 3 Newton force that will induce a counterclockwise moment, so it's positive, times its moment arm distance, given that this is L over 3, therefore half of it is L over 6, times cosine of this angle, given this is 60 degrees, and this one here is 90 degrees, therefore the length left here should be equal to 30 degrees to get a sum of 180. So this is cosine of 30 degrees. And then plus W over 2, that will induce a counterclockwise moment, so it's positive, times its moment arm distance of L over 3 times cosine of 30 degrees, all equal to 0. Now notice that we can factor out L and divide the entire equation by L, so L cancels, and then we can simplify this equation to solve for W. So we have the negative 200 cosine of 60 degrees over 3 times 3, that's 9, plus 100 cosine of 30 degrees all over 18, plus W cosine of 30 degrees over 6 equal to 0. Now we can solve for W. So we have 200, negative 200 cosine of 60 degrees over 9 plus 100 cosine of 30 degrees divided by 18 plus W cosine of 30 degrees over 6 all equal to 0. Shape solving, we get W equal to 43.65 newtons. And this is our final answer. This is the minimum weight of the cylinder at D to cause loss of contact at point C.